Welcome to this lesson, Introduction to Blockchain Development with Ethereum, presented by Coding Bootcamps. Ethereum and Cryptography. Here is some information about our instructor and some recommended additional information or even prerequisite information. So what we learned so far, we learned about smart contracts and we learned about the Ethereum blockchain. So we know that ledgers are not new. Ledgers have been used for centuries to record asset ownerships. Cryptography is also not new. Cryptography is a technique of taking a message and using a mathematical code hiding the message from adversaries, so preventing it from being read, change it to a form that's unreadable. Only the message's intended party has the mathematical key to decode the message and return it to its readable form. Same strategy is used today to secure messages on computer networks, including government, healthcare, e-commerce, defense, the list goes on. Everybody who communicates on computer networks uses some form of cryptography. Today's cryptography techniques are much more complex than those of the past. We all use cryptography every day. Every day we conduct e-commerce or shop online. If you notice there's a URL that says HTTPS, that's the protocol that uses cryptography to secure the transactor's messages. And when a transaction completes, the transaction's details are written to the Ethereum blockchain. Just as described earlier, all transactions on the blockchain are permanent. And a blockchain uses a mathematical algorithm called a hash to ensure that records are immutable. Hashes are not necessarily part of cryptography. However, it is a mathematical function, and the hashes are often linked or presented around the same time cryptography is presented. And a hash, again, is a digest of data. So key pair encryption or asymmetric encryption is used to ensure that only the intended party can read a message. So each user has a key pair, a private and a public key. Each user's keys are mathematically related and they are generated together. All users know a user's public key. So the whole community knows a user's public key. That's the way we send information. We send information to the public key. It's no different than when we send information to your home. We have to know your home address. And again, all the community knows a user's public key. In hashing, all strings, no matter how long, can be entered into a mathematical algorithm that will output a unique string of a fixed character length. So names can be hashed, the entire text of Wikipedia can be hashed, the entire text of really any big book can be hashed to a string of a certain length. Hashing is very sensitive to changes. So even if one change in one small character will cause the hash value to change. On the blockchain, after a block is finalized, the data in the block is hashed to a unique string. That unique string is used as a header in the next block, therefore relating the two blocks together. The blocks are essentially chained together by these unique hashes. Again, if any data in any block and anywhere is changed, the hashes will change and the chain will be broken. So blockchain can be thought of as maybe change apparent, and then once that change is detected, it can be overwritten with a blockchain or a ledger or a block that has not been tampered with. So we will know if there is any tampering because we will see the change in the hash. Again, hashes are digests of data. Any data value can be stored into a fixed alphanumeric string, and there are many different types of hash algorithms. MD5, SHA-256. We can see here this question here can be hashed into this 32-character string. This way of saying a million can be hashed into this 32-character string. This 0 can be hashed into this 32-character string. And this paragraph here, which is part of the Gettysburg Address, can be hashed into this 32-character string. So how are the blocks chained together? So we could see here in this transaction 1, George and Bob are transacting. Bob is sending 100 Bitcoin to George, and we can see here Bob's account is debited 100 Bitcoin, George's account is credited 100 Bitcoin. Jay and Mark in transaction 2 are transacting. Jay is paying 10 Bitcoin to Mark, so Jay's account is debited by 10 Bitcoin, Mark's account is credited. So ultimately, this block will fill up and it'll be hashed. So this is a very simplified version of the hash. We don't want to get into long numbers. It can get a little confusing as far as presentations. But we could see here that same signature is used in the next block. And then when this block fills up, it will get its own unique signature and the blocks will all get chained together. So if there was any tampering with, say, this block right here, if George said, well, if somebody thought George deserves 500 Bitcoin, if we see something like this, the hash will change and it will no longer be chained to the next block. And this will become change apparent. And once this is detected, it can be overwritten with the correct data. So again, your public key is the key used by the public to encrypt messages for an intended party. So the public will use your public key to encrypt messages meant for you. Therefore, the community knows the public key of the user to which they want to send Ether. They have to know it. Only the intended user can decrypt the message, and that user uses the private key to decrypt the message. The user's private key is what's used to, I guess, open that mailbox and read the messages that are being sent. So everybody knows, again, our public mailing address, and then we unlock the mailbox to read the messages that were sent to us. So we could see here that Tom wants to send Kelly a message. So Tom will encrypt the message using Kelly's public key. So he'll send this message here, hi Kelly, encrypt it, and it'll become unreadable, and it'll get sent over. Kelly will receive the message, and she will use her private key to decrypt the message back to its readable form. As was previously stated, blockchains run on a distributed, decentralized network, and all computers or nodes are communicating with each other. Those computers, again, those hosts, are called nodes. And in Ethereum, all nodes are equal. They are all peers. There are no specialized nodes on Ethereum. That's not true on all blockchains. On some blockchains, we have specialty nodes. Nodes specialize. There is also one ledger, so every node contains a copy of the ledger. On some blockchains, nodes are the same, whereas on other blockchain nodes are specialized and perform specific tasks. So Hyperledger Fabric is an example where there are specialty nodes. The distributed network configuration is almost also like another layer of security. If tampering is detected on any node on the blockchain network, the affected node can be overwritten with data from the unaffected nodes. If any corruption would take place, the data can be overwritten with uncorrupted data. With distributed networks, all the nodes are working peer-to-peer. They're communicating peer-to-peer. The peer-to-peer nodes do not have a central focal point, and all the nodes host copies of the blockchain ledger. So on Ethereum, there's just one copy of the ledger, and all nodes have that copy of the ledger. Distributed networks have no central authority, and nobody is controlling the network. The redundant nature allows for fault tolerance, and if one or more peers go offline, they can be other nodes can go in and take their place. And when the offline node comes back online, they'll synchronize with the rest of the peers on the network. Distributed networks are also the least vulnerable to attack, because once an attack is detected, those nodes will just be brought off the network. And if they do come back on, they will be overwritten with the uncorrupted state of the ledger. the latest uncorrupted state of the ledger. And again, we looked at centralized networks, decentralized networks, and distributed networks. So here we talked about Ethereum encryption and ledgers, blockchain structure, cryptology, asynchronous encryption, Ethereum nodes, and distributed networks. Here is our assessment. And for additional resources, please consult your learning materials. And for additional training, please also consult your learning materials. And next, we're going to look at what makes Ethereum special.